Right now, somewhere deep in the quantum world, the past might not be as solid as you think. Yesterday, that awkward conversation you had, it might not have really happened, or at least it might not have to count. Sounds like science fiction, right? But quantum physics, the weirdest, most rule-breaking part of reality, has a history of turning everything we assume about time on its head. And humorously, it's the universe's way of proving that history isn't just written by the victors. It's maybe written by particles that couldn't care less whether your prom photos exist. Here's where it gets fun. Quantum mechanics doesn't play by the one thing at a time rules we're used to. At the subatomic level, particles can exist in multiple states at once, jump from one place to another without moving, and even influence each other instantaneously across impossible distances. And some experiments hint at something even stranger: the possibility that measurements made today can retroactively influence events that have already happened. Imagine sending a text now that somehow changes how your breakfast unfolded yesterday, or spilling coffee and then somehow undoing it by waving your hand in the future. Quantum physics is basically the world's most chaotic time travel prankster. Take the famous delayed choice experiments. Physicists like John Wheeler designed setups where photons, tiny particles of light, seem to decide whether they behaved like particles or waves after they've already gone through a measuring device. In other words, the universe waits, watches how you measure it, and then retroactively decides what the particle did. And humor sneaks in because it's as if the photon is rolling its eyes at humans. Really? You're watching this now? Fine, I'll be the way you want me to be. Happy? Reality suddenly becomes less like a strict ledger and more like a cosmic suggestion box. But it's not just light playing games. Quantum eraser experiments show that even information about the past can be erased after the fact, seemingly rewriting what happened. In the lab, scientists can set up systems where knowing, or not knowing, certain information changes the pattern of outcomes retroactively. It's like the universe has a forget me button, and it presses it at random times just to mess with our sense of cause and effect. And humorously, this is quantum physics' way of reminding us that history may not be as permanent as we like to believe. Now, before you start panicking about rewriting your personal history, like unsending embarrassing texts or unbreaking a favorite mug, here's the catch. These effects are extremely delicate and happen only in tightly controlled quantum systems. In the messy, chaotic world of daily life, past events are encoded in countless interactions and measurements, making them basically irreversible. So don't go expecting to undo that awkward Zoom call. But at the microscopic level, the past is surprisingly malleable. And humor comes naturally when you think about how much more obedient the universe is in labs than in your actual life. Even more mind-bending is the connection to time itself. Quantum physics suggests that, at a fundamental level, the universe doesn't always obey our linear view of past, present, and future. Time might be more like a dimension we can move through, with now being just a point in a broader, probabilistic landscape. That means the idea of an unchangeable past is, perhaps, just a convenient illusion. And humorously, it's the kind of illusion that would make your high school math teacher scream if they ever saw a photon deciding its past based on your future choices. Philosophically, this raises fascinating questions. If the past can be erased or altered in the quantum sense, what does that say about memory, history, and causality? Are we living in a universe that's constantly rewriting itself, only appearing stable because of the massive number of interactions that lock in certain events? Or is the quantum world a hidden layer where reality is still fluid, and we only perceive solidity because we're too big to notice the tiny rewrites happening underneath? And humorously, it's a bit like realizing your favorite streaming service has been quietly editing episodes while you weren't looking, except the episodes are reality, and the edits are happening at subatomic levels. These ideas aren't just thought experiments, they've been tested in laboratories around the world. Quantum eraser experiments, delayed choice setups, and entanglement studies all suggest that the universe is stranger than we thought. And yet, while particles play fast and loose with the past, the macroscopic world, the world of cats, coffee mugs, and Monday mornings, remains stubbornly consistent. The contrast is hilarious. Particles that obey no rules, and humans who complain endlessly about rules we do have. But humor aside, the implications are staggering. If the past can be influenced, even in tiny ways, it challenges our notions of determinism and causality. Maybe events aren't fixed until observed. Maybe reality is a web of probabilities, and the act of measurement weaves one outcome into the tapestry we call the past. And humorously, it's as if the universe set out to teach us humility by reminding us that even what we think is done isn't necessarily done at all. And here's the kicker. While we can't retroactively unspill coffee in your kitchen, understanding quantum erasure and delayed choice gives us a glimpse into a world where information is the true currency of reality. Knowing, not knowing, observing, not observing, all of it shapes what was. In that sense, quantum physics isn't just about particles and waves. It's about how knowledge, observation, and information interact with time itself. And humor comes naturally, because the universe seems to be saying, "You think you understand? Cute. Let me show you a loop." Finally, these experiments hint at something almost poetic. The past might not be an immutable ledger of events, but a canvas, flexible and intertwined with the present and the future. The universe isn't cruel, it's mischievous. It's a playground where the tiniest bits of matter flirt with time in ways that defy common sense, reminding us that reality is far more fluid, surprising, and occasionally hilarious than we ever imagined. And maybe, just maybe, that means every memory you cling to has a hidden story, one that could be rewritten by the subtle, invisible brushstrokes of quantum uncertainty. Now that we've dipped our toes into the bizarre world of quantum erasure and delayed choice, let's wade deeper into what this could mean, not just for tiny particles, but for the very idea of the past itself. Because if subatomic particles can retroactively decide what happened, the implications for reality, memory, and causality are enormous. And naturally, humor follows. The universe isn't just rewriting history, it's doing it with a sly wink, as if to say, "You thought you understood time? Adorable." Consider the classic double-slit experiment, the one that turns physics into a full-on existential comedy. Electrons, or photons, or any tiny particles are shot through two slits. If no one observes which slit they pass through, the particles behave like waves, creating interference patterns. But if you measure them, they act like solid particles, going through one slit or the other. Now here's where it gets mind-bending. In the delayed choice version, you can decide whether to measure the particle after it has passed through the slits. And the particle behaves retroactively as if it knew what you would do. Humor sneaks in because it's like the electron is rolling its tiny eyes at humanity, sighing, "You think you're in control? Cute. Watch this." Suddenly, the past isn't a fixed record. It's negotiable, at least at the quantum level. Then comes the quantum eraser twist, which is basically physics' way of saying, just when you thought you had it figured out, here's a plot twist. In these experiments, scientists set up a system where information about a particle's past behavior can be erased after the fact. Remove the knowledge, and the interference pattern reappears. Keep the knowledge, and it doesn't. It's as if reality itself asks, "Do you want to know?" Fine. Your answer retroactively changes what happened. Humorously, it's the ultimate choose-your-own-adventure story, except the story is the universe, and you're the reader who doesn't quite understand the rules. But what does this mean for larger-scale reality? Could quantum mechanics, in theory, allow events to be altered after they've occurred? For now, the answer is mostly, probably not for your coffee mug, but the thought experiment is what matters. The universe at a microscopic scale doesn't care about classical notions of time. Past, present, and future aren't strictly linear. Instead, they exist as a probabilistic landscape where observation locks in certain outcomes. And humor emerges naturally when you think about how little this matters for everyday life. Your spilled coffee still stains the counter, but your cat may have technically existed in multiple states while you were trying to clean it up. Schrödinger would be proud. The philosophical implications are staggering. If the past can be influenced, even in principle, it challenges our notions of determinism. History, long thought to be immutable, could be fluid under certain circumstances. Memories might not just be recollections, but part of an ongoing quantum negotiation. And humor sneaks in here because the idea is both exhilarating and frustrating. Every embarrassing moment might be negotiable at the microscopic level, yet you're stuck living with it. Imagine explaining this to your therapist. Well, technically, I could have erased that awkward handshake, but quantum uncertainty forbade it. This interplay between observation and the past is a reminder of how central knowledge is to reality. In quantum physics, it's not just the particles themselves that matter, but the information we have about them. To know, or not know, can retroactively shape the past. Humor enters naturally here because it implies the universe has a sense of irony. Every time we say, "I wish I hadn't done that," quantum mechanics quietly whispers, "Maybe you didn't. Maybe you did. Depends on who's looking." It's cosmic schadenfreude, served with a side of uncertainty. Now let's take a slightly more tangible example, entanglement. When two particles are entangled, a change in one instantaneously affects the other, regardless of distance. Some interpretations suggest that measurements on entangled pairs could, in theory, influence their shared history. It's as if the universe keeps a ledger of correlated events and allows those entries to adjust based on current measurements. Humorously, it's like the cosmos is a gossip columnist. "Oh, you measured that photon in Paris? Let me update what happened in Tokyo accordingly." Reality is socially networked, at least at the subatomic level. Time travel enthusiasts and sci-fi writers love this idea, naturally. Quantum erasure and delayed choice experiments are essentially real-world versions of retroactive timeline edits. If we could harness these effects at larger scales, which we currently cannot, then altering the past might not be impossible, just unimaginably difficult. Humor comes naturally because humans spend centuries dreaming about changing the past, and the universe responds with tiny, almost imperceptible glitches at the particle level, as if saying, "Nice try, but maybe stick to correcting typos in emails for now." The implications extend even further when we consider the role of consciousness. Some interpretations of quantum mechanics suggest that observation, potentially even conscious observation, collapses probabilities and shapes reality. If so, our awareness doesn't just exist passively, it actively participates in the determination of what was. Humor sneaks in again. Every time you replay an embarrassing memory, argue with yourself over a decision, or obsess over what if, you might technically be tinkering with the quantum probabilities of the universe. Not enough to undo the prom disaster, but enough to keep your ego entertained. Of course, skeptics argue that these quantum effects are limited to the microscopic realm, and scaling them up to influence the macroscopic past is currently impossible. But the very fact that particles play such mischievous games challenges our intuitions. The past, far from being a rigid timeline, could be an emergent property that only appears stable because of the sheer number of interactions in the classical world. Humor emerges naturally here, because we're like characters in a sitcom complaining about our schedules while the electrons are running a full-on reality show behind the scenes. And here's where it gets even more fascinating. If we accept that past events can be influenced, or at least rewritten, on a quantum level, it reframes everything about causality, memory, and history. Even the simplest actions, if observed or manipulated differently, could theoretically lead to alternative outcomes. While we can't rewrite national elections or accidentally unspill coffee on a massive scale, the principle suggests that reality is fundamentally less fixed than we thought. Humor is unavoidable because it's like discovering the rulebook of life has footnotes written by prankster physicists. Finally, the implications are existential. If the past isn't absolute, then life becomes less a rigid story and more a dynamic narrative in which observation, knowledge, and curiosity actively shape the outcome. Humor becomes an essential tool to navigate this uncertainty. It allows us to embrace absurdity, marvel at paradoxes, and even laugh at our own tendency to panic over things that may never have been set in stone to begin with. Quantum physics, in this light, is not just a collection of equations. It's the universe's way of inviting us to play along, question assumptions, and enjoy the comedy of existence, glitches, and all. As we dive into the implications of quantum physics and its strange ability to rewrite what has already happened, it becomes clear that our understanding of the past isn't as solid as we've been taught. We've always been told that history is a fixed record, a sequence of events leading from cause to effect, like dominoes falling in a perfectly ordered line. But quantum mechanics throws a wrench in that tidy picture. At the microscopic level, events exist as probabilities until they're observed, and even then, that observation can ripple backward, subtly shaping what we think of as the past. Humorously, it's as if the universe is the ultimate practical joker, giving us the illusion of control while quietly tweaking the rules behind the scenes. Take entanglement, for example. When two particles are entangled, measuring one instantly influences the other, regardless of distance. Now, if the choice of what to measure can retroactively affect the past, then in a sense, the future can talk to the past. It's like reality is running a cosmic group chat, where messages get sent backward, but nobody told you about the read receipts. And the humor here is unavoidable. Imagine trying to explain that to your high school history teacher. Yes, Mrs. Carter, I can prove that the outcome of the American Revolution changed depending on what I chose to think about yesterday. No, I'm not skipping class, I'm doing science. Then there's the quantum eraser experiment, which essentially allows the universe to forget what has happened. Scientists can set up systems where information about a particle's past is erased after it's been measured, and the interference pattern reappears as though the measurement never happened. The takeaway? The past isn't always set in stone. And humorously, this mirrors our own lives. We've all tried to erase embarrassing moments from memory, though unlike photons, our attempts are less effective and usually involve crying into blankets or posting vague tweets at 3 a.m. Reality, it seems, has a far more elegant undo button than humans do. The implications for our understanding of time are staggering. We like to think of time as a straight line, past, present, future, but quantum experiments suggest it might be more like a web, where events are interconnected in ways that defy linear logic. Your actions in the present could, in theory, influence the past at the quantum level, while events in the past shape your present experiences. Humor sneaks in naturally here because it means that every minor choice, what to eat for breakfast, whether to answer that text, could theoretically be part of a network that spans past, present, and future. And yes, your universe might be silently laughing at your obsession with deciding between cereal or toast. Now, before you start thinking you can use quantum physics to undo all your mistakes, let's be practical. These retroactive effects happen at the subatomic scale, not in your kitchen or office. You won't wake up tomorrow to find your burnt toast suddenly perfect. But the principle itself is mind-bending. The universe isn't strictly deterministic, and the past isn't as immutable as we've assumed. It's the difference between a solid, unchangeable record and a probabilistic map that can shift based on observation. And humor is unavoidable here, because it's the closest we'll ever get to being time travelers without leaving our beds. Philosophically, this raises enormous questions. If the past is not fixed, then memory, history, and even personal experience become more malleable. Our brains encode events as real, but quantum mechanics suggests that reality at its core may remain fluid until measured or interacted with. Humorously, it's as if our minds are trying to keep a diary of a story that's still being edited by a cosmic author with a wicked sense of timing. Every regret, every triumph, every tiny awkward conversation might be part of a quantum dialogue, constantly being reshaped in ways we barely perceive. Even consciousness might play a role in this process. Some interpretations of quantum physics propose that observation, potentially conscious observation, is what collapses probabilities into actual events. That would make us active participants in the formation of reality, not just passive observers. Humor sneaks in again. Every time you replay a memory, overthink a decision, or obsess over an outcome, you might be participating in a subtle shaping of reality itself. Not enough to erase that typo in your last email, but enough to remind you that your thoughts are far more powerful than you realize, at least on a quantum scale. Let's talk about causality. We're used to thinking of cause and effect as rigidly linked. A happens, then B, then C. But in the quantum world, causality is more like a complex dance, where effects can ripple backward and forward, weaving a network of interconnected possibilities. Humor enters here because humans cling to linear logic desperately, as if clinging to the rails on a roller coaster designed by mischievous particles. The universe, in contrast, skips and pirouettes, occasionally giving us glimpses of the underlying choreography, like an impromptu flash mob in the lab. Even if these effects don't scale up to the macroscopic world, they teach us a profound lesson about uncertainty and flexibility. The past may be more malleable than it appears, and events might not be as locked in as our memories insist. Humorously, this could explain why people are endlessly fascinated by what-if scenarios and regretful thoughts. At some deep, intuitive level, we sense that reality might be more like quantum clay than concrete. And unlike clay, it's shaped not just by external forces but by observation, attention, and interaction, plus a generous sprinkle of cosmic irony. Time, it seems, is both a guide and a prankster. It moves forward, yes, but it also loops, flexes, and interacts with information in ways we barely comprehend. Quantum physics reminds us that the past, while seemingly fixed, is dynamic at its roots. And humor sneaks in when we realize that every minor worry we've had about what has already happened might be less significant than we thought. That spilled coffee, that missed train, that awkward conversation, maybe the universe is quietly giving us a second chance, just beyond our perception. This isn't just philosophy, it's a call to rethink how we live. If the past isn't absolutely immutable, then our approach to life can shift too. We can embrace uncertainty, experiment boldly, and laugh at absurdity with less fear of permanent consequences. Humor, as it turns out, is the perfect companion for a universe that can erase its own history. It allows us to navigate chaos, accept imperfection, and enjoy the cosmic game even when the rules are mind-bendingly strange. Finally, reflecting on quantum erasure, delayed choice, and entanglement, we arrive at a profound perspective. Reality, past, present, and future are far more fluid than our everyday experience suggests. Time isn't a straight line. It's a probabilistic web, influenced by observation, information, and interaction. The past, while seemingly fixed, may be flexible on scales we rarely perceive. And humorously, that means life is less about rigid outcomes and more about participation, curiosity, and enjoying the unpredictable play of existence. So, as you walk through your day, think about the moments that feel slightly off. Those instances where reality seems stranger than expected, where coincidence, chance, or misfortune hint at deeper rules at play. Whether quantum effects are directly shaping those events or not, the very idea invites us to embrace flexibility, curiosity, and humor. Life, it seems, is not just a story of what happened, but a dynamic, interactive adventure, filled with the possibility that some things we call the past are still, in a subtle way, being written. And maybe, just maybe, the universe is laughing along with us, at our seriousness, our panic, and our stubborn insistence on linear time. Because even if the past can't be literally erased in daily life, it's a playground where reality is more flexible, more fascinating, and far funnier than we ever imagined.